Next, we'll move on to the topic testing software of different technologies. The principles of the testing are same, but applying these principles to test different technologies, it comes with the experience. So, in your testing career, it is likely that you may need to test a software for different technologies, and hence it is necessary to gain the sufficient knowledge of those technologies and to learn the problems of testing a software in different technologies. So we'll now consider first we'll consider the client server software, right? How do you test it? So client server software, it is widely used software nowadays, right? So using a standalone application is rather limited. So in client server systems, the resources are available on the server that are accessed by multiple clients simultaneously. So the testers need to keep in mind that all the clients may not use the same hardware and software, and in spite of these differences, the software should work. Even when the multiple clients access the same resource, say suppose a database, continuously or simultaneously, the response should be very fast. So if the system becomes slow, it is not acceptable. The communication link between the client and the server, it also affects the performance. Apart from this, you have to check for the security as well in the client server softwares. Next is your web based applications. So, internet and intranet based applications are now gaining popularity. Say, whether it may be testing of your small site or web service or maybe a e-commerce application. So these have some issues. So the issues are like the application has to work on different browsers, right? And most applications are tested only for one browser, and for other browsers, whenever you open the site, it might look bad, the UI might be distorted. Okay, so each and every link on that page has to be tested. Each page download should not take more than 10 seconds. The audio, video, whatever is present on the page has to be done with tested with additional care. Again, security is also important feature here, right? The next one is object oriented software. So testing the object oriented software, it poses special challenges. So the first one is like reuse. Reuse is the most attractive feature of your object oriented programming languages. So it is likely that some portion which are present in that code has been developed elsewhere, and it is used in another projects. So adapting the code written for some other project has to be done very carefully here. Similarly, the code that is being given to the other groups for adaptation has to be tested thoroughly. Okay. The next one is mobile applications. In the mobile applications, so the mobile phones, smartphones, so we have to test all these things. The site, maybe you have to test it on a mobile. So what are the things you do in a mobile? So you can access internet, you can check your mail messages, right? Or even you can open the mobile commerce, mobile learning, etc. So these are, you know, basic applications, whatever you can open through these mobile devices. So developing mobile applications is different from developing desktop applications. Why? Because mobile we have small display size, low bandwidth of network, then high delays and different mobile communication protocol issues has to be tackled. So testing of the mobile application, it also involves testing a simulated environment using mobile phone emulators and then deploying the application over the network for field trial. First, what you have to do, you have to check or you have to test the application in your system using a emulator. Okay, then once you have gained the confidence, like once you have, once you are confident that your software works, what you have to do, you have to put that into the mobile and you have to test it on the mobile, right? Next, we'll talk about metrics in testing phase. So During every phase of your software development, metrics data needs to be collected. Okay, the metrics, they'll help in the monitoring the process of the project and also improving of the process. So this metrics data, it means like some numbers or the capacity, amount, or size of some attribute. Okay, so the matrix in the testing phases are your, the first one is the estimated time for your testing phase and the actual time taken for the testing phase. So before starting the testing phase only, you should have your estimated time for testing process. That means how much time would be required for your testing process, and then you have to compare this one with the actual time. This actual time is nothing but when your testing process is currently in progress. So during the planning stage, the time required for the testing phase is estimated or calculated based on your past experience or using historical data. So while executing the project, the actual time taken for the testing is measured. So if two values are close to each other, then it can be concluded that the estimation process is good enough. Otherwise, we say that the estimation process, it needs improvement. Okay, the next one is budget, estimated budget for the testing phase and the actual money spent or the actual budget for the testing phase. So these values also help in improving your estimation process. Next one, the estimated effort for testing phase and the actual effort. This means the manpower required, that is the effort is measured in person months, right? How many months you required, how many year you required, and how many person you require for the testing. Next one is defects density. So this is nothing but the number of defects that is found per thousand line of code. Okay, the number of defects that is found out per thousand line of code is called as defect density, and this gives an indication of the quality of the software you have built. Next is number of defects that is found per unit time, that is per week, per 15 days, something like this. So during the testing phase, the testing team has to keep track of the number of defects found per week or per fortnight or per day, something like that. Okay, now tracking this data, it helps in finding out when the testing can be stopped. The last one is cost of quality. So the three components of quality are the failure cost, appraisal cost, and prevention cost. So these three things we have already seen in our previous discussion. Next, we will study about when the testing will be completed. Okay, when do we say testing is complete? So it is very difficult task to say when the testing is complete and when product has to be, it has to be released. So you keep on testing the software. So it may happen that you keep getting a defect. Okay, so whenever you test something, you might get some defect, and this process might go on forever, right? So on the other hand, you might not get any defect. But what is the guarantee that there is no hidden defect in that? And the defect, it may show its effect on the day of the software that would be delivered to your customer. You might not get any defect. You might think that, okay, there is no defect in the software, it is working as expected. But there might be a case that whenever you deliver the software to the client or just a day before the final delivery, you might end up getting a defect, right? So you cannot actually say when you can stop testing. So after all the effort you have spent in developing of the software and testing of the software, you are not sure whether it is ready for shipment, whether you can deliver the software or not. So now this proves our point one more time, right? What is the point? That is, testing is difficult. So instead of relying on your gut feeling, that we would arrive at a scientific method to declare that the testing is complete and the product is ready for the shipment or the delivery. So what are the criterias, you know, uh, for completion of testing? So the first criteria would be, so whenever you run out of time. The second one, whenever you run out of your budget or money. And the third one is based on the statistical criteria. Okay, so in the practice, so whenever you run out of time and money, so you at that time you stop your testing. So this is usually followed, right? So during the planning stage, certain time and effort or the money is allocated to the testing process. The test team keeps testing the software, and when they run out of the time or money, the product will be delivered to the client. Why? Because to avoid the penalty of the late delivery of the software. So most managers do not realize that this is very dangerous practice, because if the software, if it fails at the customer side, then the reputation of the organization would be lost. So a more practical approach is used to, is using the third point, that is based on the statistical criteria. So after the coding is completed and the testing begins, initially many defects are detected, then slowly the number of defect found, whatever you have found, will be less. Okay, and it keeps on reducing the day after or the week after. So it is something like this in the shown figure, right? This graph, it says, in the x-axis you have the week progressing, and you have on the y-axis the number of defects found per week. So if the number of defects found per week it remains less than that of the predefined threshold consecutively for 3 days, then the software can be considered as a mature product and it can be released to the client. Okay, so this is about the criteria for completion of testing. When can you say the testing is complete? Either you run out of time and money, or based on the some statistical criteria. Okay, next we'll see about defect seeding. So this we have already seen, right? So we had seen debugging, right? Debugging or defect seeding. So this is defect seeding is another method which describes or which tells when you can finish the testing. Okay, so in the defect seeding, what we will do, you'll intentionally add some defects to the code and the testing team is asked to detect these defects. Okay, so for example, if you have 100 defects that are intentionally introduced in the code and the testing team is able to find out 90 of the defects out of 100, they have say found 90 defects, then we can conclude that 10% of the defects are undetected out of intentionally introduced defects. So that means it is likely that your software is likely that 10% of the actual defects are not detected by the testing team. So based on this conclusion, we can estimate the residual defects or the latent defects in the software. Okay, so we can have a formula for that, that is latent defects or residual defects is equal to total defects found into the total defects intentionally added to the code divided by the seeded defects found minus 1. I'll give you an example. So say for example, during the testing, say you have found 300 defects in the software. Okay, so total defect found is like 300. Okay, and say that whenever say suppose you have intentionally added 100 defects in the system, and out of that 100 you are able to find out 90 defects. Okay, so I'll repeat once again. So say suppose the total defect found till now in the software is 300, and say suppose the testing team said we have not found any more defects. So can we say that the testing is complete? At that time we can use this criteria, that is defect seeding. So say suppose they have found out 300 defects, and say suppose you have intentionally added or seeded defects like 100 defects. Okay, so the total defects intentionally added or seeded is say suppose 100. Okay, then out of those 100 defects, and it has been given to the testing team. Okay, now out of this intentionally added defects, like out of 100, say suppose the testing team has found out 90 defects, that means seeded defects found, that means 90 minus 1. Okay, so it is 90 minus 1. So altogether whenever you calculate this one, so you'll end up having the result as 34. Okay, so using this criteria, we can say that still 34 defects might be present or it would be present in the software which are undiscovered by the testing team. Okay, so this is defect seeding is another criteria to check whether the testing is complete or not. That's it for today. We'll conclude our session. Thank you.